So this lecture is on state diagrams, which is another one of the UML diagram types, and in particular one of the ones that you're going to have to do for your homework assignment. Oops, sorry about that. So the idea of the state diagram, another one of these sort of blueprint pictures of what our system does, is its purpose is to depict some parts of the dynamic behavior of a particular object or a particular class of objects through its lifetime. In other words, as it progresses through the system, what things change about it. So for that particular object or that class, there will be a set of states, including a starting state, and then transitions between those. And what I want you to understand here, and we'll go over it again during the class times, is when we talk about states, a particular object could have several different state variables. And the state is really tied to a particular variable. So we're looking for variables that take on a finite set of values that aren't simplistic. In other words, like technically age is a state, but it monotonically increases. You go from age 1 to age 2 to age 3, and it's done at a particular calendar date. So that's not really a state. What we're looking for here would be examples like your classification as a student. You're a sophomore, you're a junior, you're a senior, you're a freshman, and there's particular rules that define when that progression is, but it may not be exactly the same for everybody. It doesn't occur always on a particular calendar date, etc., etc. And those are characteristics that you take on throughout your lifetime. In this case, those don't repeat. Sometimes you can go back to other states in some kinds of state diagrams. That particular example you would not. But also things like, for example, your standing at the university. You could be in good standing, you could be on probation, you could be suspended, you could be expelled, you could be graduated. In some cases, you can go back and forth. You can go from being in good standing to being on probation to being back in good standing, or to be on suspension and then be back on probation and then be back in good standing, etc. So these are similar to things called finite state machines, which if any of you started taking digital logic or anything yet, you may have already encountered those. Okay, so every class that we define in our system may or may not have states associated with it. Some classes may have multiple states, which means multiple diagrams. Some classes may have no stateful variables. Okay. So how many we'll have will depend on what the data is and how dynamic it is. Here's a very simple example of a state diagram. Let's think of this one as for like a safe, like you would keep your valuables in or whatever. And this one has kind of a weird algorithm, but the idea here is that I start out in a wait state, so that initial state, that one on the far left, is where I'm starting, and the final state, which looks kind of like a bullseye, is where I'm ending. In other words, as far as the system's concerned, it's over. The wait state is my starting state, and it says that under the condition that under the event that a candle is removed and the door is closed, I'm going to reveal the lock. And of course it's locked, but I can open it. If I turn the key and the candle is available, then that's going to result in the action of opening the safe, and now I'm in the open state. And then if somebody closes the safe, we call that a transition, I go back to the wait state, and I'm waiting again to see about the candle and the key. I admit the candle part is kind of weird, but that's okay. So the idea of a state then is this, based on the field variables, some particular situation I'm in, and I don't leave that until some event occurs. So I start out from an initial state, which is typically not a really existent state, and I go to the first active state, whatever that is. In this case, it's wait. And again, we're doing this from the perspective of a particular object or class. And a transition is where I move from one state to another. A transition can have all these different pieces on it, all or virtually none. It always has to have a signature or an event, something that causes the state to change from one to the other. So for example, here it's the candle being removed, but in the case if this were like freshman and sophomore, the trigger event would be you've completed 30 credit hours. Then you would transition from being a freshman to a sophomore. So this condition here would be credit hours greater than or equal to 30. Okay. A guard condition, this thing inside the brackets, indicates that there's some other condition that needs to be true. So, for example, if this were freshman, sophomore, it could say greater than or equal to 30 hours, and this could say in good standing. In other words, you can't move from being a freshman to a sophomore unless you're also in good standing, as well as having more than 30 credit hours. And then the slash here indicates that there's some activity that's done as part of the transition. So in this case, it reveals the lock. In the case of the freshman to sophomore, maybe we sent you a letter that said, congratulations, you're now a sophomore, or it updated your status on EIS, or whatever. So whatever the activity that needed to occur as we're doing this transition. And notice all these transitions are directional, so there's always going to be an arrow on them. These transitions, oops, I wasn't supposed to do that yet. These transitions need to be mutually exclusive. That means that if there's more than one transition out of a state, which there can be any number of transitions out of a state. But when I look at all the conditions, all the signatures, if you will, they have to be mutually exclusive. In other words, there can't be any overlap. And they also have to be complete, even though it doesn't say this here. It has to be mutually exclusive and complete. There can't be ambiguity about which way I'm going to go. All the rules need to be clear. So if I have a rule that says greater than or equal to 30, there's an implied rule of less than 30, meaning I stay in the same state. And I could actually diagram that as a little loop that stays in the same state. As long as my credit hours are less than 30, I stay in the freshman state. Okay? And those would be mutually exclusive. In other words, there's no ambiguity about which way I go. I'm either less than 30 or I'm greater than or equal to 30. And they're complete. They cover every possible situation. In other words, I know what to do under every possible condition. Okay? So it has to be clear, and in those cases, the transition is instantaneous, although there may be an action to accomplish along the way, like revealing the lock or sending a letter or whatever the case may be. We can also have internal activity inside of a state. In other words, things that happen as we're in that state. Possibly it's, for example, in some hardware systems, it might be a polling. We're polling some port to see if the user's plugged in a USB drive or something like that. And so we're constantly doing activity to see if the trigger event has happened to cause us to go to another state. We can have entry and exit activities too. None of ours will be quite this complicated, I don't think, for this first homework assignment. You can also have sort of superstates and substates, in other words, where one state is nested inside of another. Like here's something that has to do with connection details, and then that's part of a bigger state, which has to do with my connection activity. Just don't get too overzealous about this. So for example, being in good standing could be a substate of being in the different transitions, or being eligible to graduate could be a substate inside of your in good standing state. Okay, so we can have nested ones as well. Again, I don't think your homework will require anything this complicated. If you're starting to think in terms of things that are this complicated, you're probably way overthinking the problem, or just creating additional busy work for yourself and not actually focused on what the real problem is. And we'll do some examples related to things like the grade book and stuff in class, so you'll have some very targeted examples of what state might be. And we'll also talk a little bit more about how to identify state in class, because it's a hard concept when you first come across it, because it's not natural. It turns out it's actually pretty easy, but it's sometimes difficult to understand at the very beginning. So we'll do some more examples with this during the class periods, and of course you can bring your questions then as well.